we are again trying to figure out if this is an acute or an obtuse or a right triangle, since we don't have any angles given to us. And we're going to use the Pythagorean theorem and set it up like we normally would. A squared plus b squared equals c squared, but we don't really know for sure if it does equal. And if we find out that they're equal, great, it's a right triangle. But if this side ends up being larger, then it's going to be acute. If this side ends up being larger, then it's obtuse. Okay, so the first thing you need to do is figure out what your hypotenuse is. What's the longest side? And when you say 2 times the square root of 33, you might need to plug that in your calculator to compare that to 8 and 14. 2 times the square root of 33 ends up being a little bit more than 11. So this 14 is still going to be your hypotenuse, your longest side, your C value, if it's a right triangle. Okay, so that's, for now at least, that's what we'll call our hypotenuse, even though we don't know if it's truly a hypotenuse. We'll plug that in for C and call that 14, and we have to square it. I'll call this side A, so that's 8, and I got to square that. And then this last side, 2 times the square root of 33, will be our side B, and we have to square that. And again, if this is a right triangle, these are going to equal one another, but they might not. And if they don't, then it's going to have to either be acute if the left side's larger or obtuse if the right side's larger. Okay, so let's do the math with all of this. 8 squared is 64. 2 times the square root of 33, well, that's like 2 squared is 4. Square root of 33 squared is 33, so altogether that's 132. And 14 squared is 196. Okay, so when I add these two sides, or 64 and 132 on the left-hand side together, that's 196. Is that really the same as 196? It is. All right, so this Pythagorean theorem with an equal sign is really true. The sides balance out, so this actually is a right triangle, and that right angle must be there across from the hypotenuse.